The curve C with equation y equals f of x, where x cannot equal 0, passes through the point 3, 7.5. Given that f dash of x is equal to 2x plus 3 over x squared, part A, find f of x. So I know that this is my gradient function because of the f dash. So to take that and turn it into the original f of x function, I need to integrate. So I need to integrate 2x plus 3 over x squared with respect to x. Now the 2x will integrate easily, but the 3 over x squared, I'm going to rewrite that as 3 times x to the power minus 2. Now I can integrate each of these terms. The 2x, well, I'll add 1 to the power and divide by the new power. Next, again, we will add 1 to the power. So minus 2 plus 1 is minus 1. And then divide by the new power. And don't forget your constant of integration. So this is my f of x, which I can simplify a little bit. The 2 divided by 2 is just going to be 1, so they'll cancel out. And the 3 divided by minus 1 will be minus 3. Now, I need to work out my constant of integration, c. And I'm going to do that because I know that when x is 3, y is 7.5 or 7.5. So if I substitute that in then, let me just create a little bit of room. So we're going to substitute the 3 in here and here, and we're going to substitute the 7.5 in here. So 7.5, or that's the same thing as 15 over 2. Or you could say 7.5 if you prefer working with decimals, is equal to 3 squared minus 3 times 3 to the power minus 1 plus c. Three squared is 9. This 3 to the power minus 1 here is just like me writing 1/3. So that's going to simplify to be 1 plus the c. So 15 over 2 is equal to 8 plus c, and c is going to be equal to minus 1/2, which I can plug in there to get my final equation. So in blue there, that is my f of x. So basically just integrate and then substitute in the coordinate to work out your constant of integration c. Part B says to verify that f of minus 2 is 5. So I'm just going to substitute minus 2 into my function, and hopefully I will get 5. So minus 2 squared minus 3 over the minus 2. This x to the power minus 1 just means the x is on the bottom. Minus 1/2. So we have minus 2 squared is 4. Minus 3 divided by minus 2, that's going to be a plus 3 over 2. Minus 1/2, and yes, that does equal 5. Now, part C says to find an equation for the tangent to the curve at the point when x is minus 2 and y equals 5, giving my answer in this form. So tangent, straight line, y equals mx plus c, and I can find my gradient m by substituting my x coordinate into the gradient function, which usually we would do by differentiating. In this case here, I don't need to do any differentiation because I was already given the gradient function at the very beginning of this question. So that saves me a job. I don't need to do any differentiating. All I need to do is substitute minus 2 into that gradient function. Which gives minus 4 plus 3/4, which is going to be minus 13/4. So that is my gradient. Right, y equals mx plus c. So y equals minus 13/4x plus c. And we're substituting in our coordinate that the tangent goes through. So the y coordinate is 5 when the x coordinate is minus 2. Minus 13/4 times minus 2 is going to be a plus 13/2. Which tells me that the c is going to be minus 3/2, which I can plug in here. And all I need to do now is to rearrange that in the form of ax plus by plus c equals 0. So to do that, I'm going to multiply all the way through by 4 to simplify these fractions. So I'll get 4y, a minus 13x, and the minus 3/2 times 4 is going to be minus 6. Add the 13x to both sides, add the 6 to both sides, and this is my answer.